All right, this is going to be part one on finding range, interquartile range, and outliers in data sets by actively participating in the lesson and scoring 80% or higher on our Google form. Today we're starting to learn about how data varies. So up till now we've been focusing on identifying the center of data with an individual number because we like to summarize data in that way. But we are also interested in statistics and how much data varies. So I discussed how many siblings we have. And I think that we'd be surprised that some students have 0 siblings while other students have, 9 or 10 siblings. And that data varies quite a bit. So that's what we're going to begin to measure, is measuring how data varies. Now I have here a couple of statements about student quiz scores that were submitted last week. So the first statement is the quiz scores range from 65 to 102. And the second statement, most of the students earned A's or B's. So those are both true statements about the data that was collected on the 1st of May. Now, I did not include data from students who submitted their quiz late. Now, using that information, couple of questions we could probably answer from these statements. When it says the quiz scores range from 65 to 102, most of you understand that that means that the lowest score on the quiz was a 65 and the highest score on the quiz was a 102. So we can use that information to know there was at least one student who did poorly and got a 65. There was at least one student who did very well and earned a perfect score of 102. But we don't know where that data, and we know how spread out that data is now. So that kind of meets our goal for today. The second piece says that most of the students earned A's or B's. So that gives us an idea of where the data cluster, because I used the word most. So now what I'm going to do is I'm going to show you a dot plot that I created of this exact data. And when you look at this dot plot, you can see, and I'm going to zoom in there, you can see that most of our data was right here. You could see that it kind of clustered in this range right here from like 92 to 102 was where most students scored. There was certainly plenty of data here. You can see 3 students scored an 80. If you look closely here, there's a dot between 82 and 84 that indicates 83. You'll recall when I talked about creating dot plots that when we make our number line, we don't skip numbers unless we're skip counting. So you can see I skip counted by 2s when I made my dot plot, but because I left a space in between 82 and 84, I could still graph an 83. And the only reason I didn't write the 83 is it was too hard to squeeze those numbers. But I did it in a very systematic manner where I counted by 2s, and then when I had odd values, I could still graph them. Now, looking at this data, again, we can see exactly what the most popular answer was. We can count to see exactly how many students scored a perfect score. Now, with this dot plot, because it's the raw data, we know everyone's score. We don't know who scored which score, but we do know everyone's score. You yourself could look at this data and then recall how you did on this quiz to see where you fall in among your peers. If you find yourself down here, then you know that you scored lower than many of your peers. Obviously, if you found yourself up here, you can feel confident that you were among the elite. Now, when it comes down to understanding data as far as how it's spread out, we're going to be taking apart data today, focusing on range. And range was the first term that I used when I said that the scores ranged from 65 to 102. And again, that means that they went from here all the way to here. Now, to calculate range is actually very, very simple. To calculate range, what you do is let me get a darker pen, you subtract the highest value and then you subtract the lowest value. Now, I like to teach you the correct vocabulary terms. So the highest value we call the upper extreme. And if you think of the word extreme, it's like something's extremely hot, then that lets you know it's the most hot, okay? And then we subtract the lower extreme. So those are the correct terms that we use to describe the highest and the lowest terms in our data. In this case, our upper extreme, this is again to calculate range. The highest extreme, or the upper extreme, was 102, and the lower extreme was 65. You'll recall I did mention that in this unit we would be allowed to use a calculator. So even though you certainly could do this in your head, we'll break out my calculator here and we'll do 102 minus 65. And what this does is it tells us that the data ranged from that amount, but we can have a single answer to describe the range. And that single answer is that difference. So the scores ranged 37 points apart. They were pretty spread out. Now, if I had told you that the students all scored, within 15 of each other, that would let me know that everyone's on track versus, the data being really spread out. I'm going to give you guys some more raw data, and these are made up data. But based on what I know about some of my peers in the school, is these are meant to be ages of teachers at Hamilton Middle School. And what I'm going to do is I'm going to take all this raw data and I'm going to put it in order from least to greatest. Let me make that a little bit bigger so you guys can see. So I'm going to put the data in order from least to greatest, and you can see I'm going to kind of rearrange things a little bit to put them in order. And you can see when I'm all done, I've got my cards in order. And if I wanted to find the range of this data, I would subtract my lower extreme. So to find my range, I would subtract my upper extreme, 62, minus my lower extreme, 24. And that's the oldest teacher minus the youngest teacher. And again, this is made up data, but I know that, that we have some teachers that are brand new right out of college, so they would be probably 23, 24 years old based on how long it usually takes to go to college. And so I'm going to go ahead and subtract 62 minus 24, and there we go, 38. So what we're looking at is a range of 38 years. That's a big difference. And that's because many teachers, start their career and then continue teaching for as many as 40 years or so. This is my 22nd year teaching, and so I'm kind of in the middle of that range. All right, so what we're going to do now is we're going to also investigate the other measure of variation that we're going to talk about over the next 2 days. I'm just touching on it a little bit, and that is to understand the interquartile range. So we know how to find median of a set of data. We just find the middle, right? And so you can see very clearly 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, that the middle of this data comes between 34 and 38. So a measure of center, we could do 38 minus 34, divide by 2, and find the median is 36. That's great. But what we're going to do to find the interquartile range is we're going to find out how spread apart the middle of my data is. And the way we do that is instead of separating it into halves, we separate it into fourths. And that's where the word quartile should make sense. We know quart is 1/4 of a gallon, or quarter is 1/4 of a dollar. So what we're doing is basically taking the upper half of the data and splitting it in the middle, and the lower half of the data and splitting it in the middle. And what we've now done is we've grouped our data into 4 separate parts. And so this item right here, so this would be our median, the middle of our data. This would be what we call the third quartile of the data. It's right in the middle of the upper half of the data. And this is the first quartile of the data. And so what we basically would do is find out a number, which would be the median of the upper half of the data. Okay, that would be quartile 3. And then we'd find quartile 1, which is the middle of the lower half of the data. And we're going to be focusing on this part of the lesson tomorrow. I just wanted to give you kind of a tidbit. So this quartile 1 would be 28, because that's the number that would fall between 28 and 28. And here, this would be 46. And so in order to find what we call the interquartile range, or the IQR, what we do is we subtract quartile 3 minus quartile 1. And you're going to notice that I'm using subscript numbers, just like we did when we identified base 1 and base 2. And just so you know, median would be quartile 2. So my median right there would be quartile 2. So if I subtract 46 minus 28, all right, that will be 18. So my IQR is 18. All right, and again, that lets me know that the middle of my data is definitely more close together than all of my data, but it's not like remarkably close together. And so, what we look for is a larger range or a larger interquartile range would indicate that the data is more spread out, whereas a smaller range or a smaller interquartile range would indicate that the data is is closer together. So I'm going to go ahead and move these out of the way. And I'm also going to zoom in my camera because I want to show you some data here. So there we go. So I'm actually going to be looking at 4 different dot plots. These dot plots are all measuring within the same range of numbers. But what I'd like to know is when you look at these 4, which data is the most spread out? Okay, and so you can look at the data, you can clearly see this is the least spread out. It's really, really close together. But if you really want to know how far they're spread out, what you can do is you can subtract the highest value, 35, minus the low value, 25, and get a range of 10. You could subtract the highest value, which looks to me like 48, and the lowest value of 13 gives me a range of 18. The highest value, which looks like 47, and the lowest value is 40, which is 7. And the highest value, 55, and the lowest value of 33 would give me a range of 22. So now that I've got that numerical value to describe how spread apart the data is, it becomes much easier to identify. And just like before, we knew this was the closest together, but now that we have a numerical value of 7, it gives us justification as to why it's closest together. We've got a numerical value that we can use to describe that data. And so the range of this data is only 7 apart. It's much more clustered, which you can see in the picture, and the range of letter D is much more spread apart, which is again obvious in the picture and numerically. So here's the book's definition. It says that a measure of variation is a measure that describes the distribution of a data set. A simple measure of variation is to find the range. The range of a data set is the difference between the greatest value and the least value. And you can see in this example, the table shows the length of several Burmese pythons captured for a study. We want to find and interpret the range of their values. So to find the least and greatest values, it's helpful to put the data in order from least to greatest, which they did here. You can see that the least value is 5 and the greatest value is 18.5. Now what we can do is subtract that to get a total of 13.5 feet. This means the lengths vary by no more than 13.5 feet. It also does give us a number that I think is rather high when comparing the length of snakes. And so I would say the range of the lengths of these snakes is pretty significant. So I would say the range is large, lets me know that this data does vary. Now we're going to go ahead and do one on our own. I'll make this a little bit smaller for you guys. Okay, so the ages of people in line for a roller coaster are 15, 17, 21, 32, 41, 30, 25, 52, 16, 39, 11, and 24. They want us to find and interpret the range of their ages. Now, ladies and gentlemen, let's be really clear here. I don't have to put all the numbers in order, but I do need to double check as I identify what numbers I think are the highest and the lowest in case I make a mistake. So right off the bat, I think 11 is the smallest number, and I think 52 is the largest number. But let me just make sure there are no numbers that are lower than 11 or higher than 52. All right, now I feel confident that I've identified the correct numbers. So in order to calculate this, what I'm going to do is 52 minus 11, which gives me a range of 41. All right, and so that is an answer that I can easily figure out by subtracting the upper extreme minus the lower extreme to find my range. In this example, we're asked to find the range again, and same situation. I'm going to take a look at all the numbers: 26, 21, 27, 33, 24, 29. And so I'm going to go ahead and carefully identify. I think 21 is my smallest. 33 is my largest. I'm going to go ahead and double check. Sure. So I'm going to do 33 minus 21. So my range, and again, if you're having trouble getting that answer in your head, you go ahead, pull out that calculator and subtract it, I can do this one and see that my range is 12. And again, I'm finding that to calculate range, I just want to see how far spread apart the data is. If I was to ask the range of student ages in my classroom, that range would probably fall, within 1 or 2 years. Everybody's about the same age. So that would be a small range. My data would not vary much. But if I ask the range of ages of people who were in a college class, that data would be a much larger range. That data would be much more spread apart. Now I have an answer analysis question for you, and I have the error analysis question. I have this here for you because this is a very common mistake students make. They say the range is 11 because they subtracted 49 minus 38. Hopefully you would all realize the mistake they're making here is they forgot to put the numbers in order. They forgot to identify the largest value and the smallest value. So the largest value is 51 and the smallest value is 35. And so as a result, their range should actually be 16. So that's a very common mistake, and I'm hoping that when you find range, you don't fall for that. You can be assured that when I create your Google form, that I'm not going to put the numbers in order for you. You're going to need to make sure you're identifying the correct number. And so paper and pencil will be a great way to assure that you're identifying the correct terms. So here we go, one of our last 2 examples to find range. So when I look at this data, first thing I want to do is identify the numbers that I think are the smallest and the largest. These numbers are not in order, although they look like they're in order. They're definitely not. That looks like the smallest, that looks like the largest. Let's go ahead and just double check. And then this one's a little harder to add, so I'm going to break out that calculator and I'm going to go ahead and subtract 174 minus 117. And I get a range of 57. And that data definitely is pretty spread apart. Now this example has some decimal terms. No reason to let the decimals bother you, but again, you want to make sure we identify the largest and the smallest value. That looks like the largest, that looks like the smallest. Let me double check. All right, I'm good. And just like before, I'll use that calculator, making sure to use the decimal point in the correct spot. And subtract 7.3. So another common mistake students make when finding the range is they accidentally divide because they're used to dividing when finding measures of center. So just be careful and recognize that range is a distance. So we're going to subtract that. Think of like a shooting range. If you're shooting a bow and arrow at an archery range, that distance from where you aim and where that target is indicates how far away you're shooting. That's what we call a range. Last thing is just a little information from the textbook on quartiles we talked about in the beginning of this lesson. So quartiles of a data set divide the data into 4 equal parts. And so the median will be called our second quartile, and that's what divides our data into 2 halves. So this is just another graphic I forgot to include earlier that I didn't want to miss. All right, great job. Good luck on your Google form.